Okay, so rational inequalities. The main goal with rational inequalities is to find the values that create zeros in the numerator and the denominator. So again, we're looking here for zeros. Let's see if I can do that a little bit better. So in a case like this, where everything's already all set, you have one rational expression. It's already set equal to 0. The two areas we have to worry about is going to be x minus 4 is equal to 0, because that, of course, would set with the inequality on the top. The other one we have to watch out for here is the 2x minus 5 is equal to 0. And the reason why this is we have to look out for the domain, or the denominator, is because it's a domain issue. And so it can't equal 0, period, done, end of story. So add the 5, divide by 2, you get it set up so x cannot equal 5 halves. I mean, that's just period, done, end of story. There's just can't happen. And so when you set up your timeline here, again, we have 0, and we've got 5 1/2, which is about 2 1/2, so that's going to be, or 5 halves, excuse me, which is about 2 1/2. And so that's going to be an open circle, and there's no way around it. I mean, it can't be filled in, period, done. Over here, this one, however, if x equals 4, I get 0 on the top. So that would be about here. And now that one is going to be filled in because, again, there's an equality sign there. Just like before, you're going to go through and you're going to test these different areas, okay? So you're going to test the area to the left of 5 halves. You're going to test the area between 5 halves and 4, and you're going to test the area to the right of 4. Pardon me. So you're going to say test x equals 0. So is 0 minus 4 divided by the quantity 0 minus 5 greater than or equal to 0? And that answer is going to be true, because that becomes 4/5. So that means that this whole area over here is true. We're going to test 3, because that's between, and again, you can pick any number, but obviously integers are going to be a little bit easier for most of these. So then we're going to go 3 minus 4 over 3 minus 5. And is that going to be bigger than or less than, excuse me, that should be 6 minus 5. I forgot that's double it. So is that going to be bigger than 0? And the answer is false. Sorry, let me finish writing this out over here. True. This is you have a negative over positive. And then lastly, over here, let's say check test. Pick a number. Any number is fine. I'll pick 10. Is 10 minus 4 going to be larger than 20 minus 5? Is 10 minus 4 over 20 minus 5 greater than or equal to 0? That is a true statement. So that means that, again, we're going to shade in that same area of the graph. And in terms of setting this up, in terms of interval notation, this is not part of the solution, so the 5 halves is going to go here. And that's going to go down to negative infinity. And then again, union 4 is included, so I'm going to put a hard bracket there. And that's going to go up to positive infinity. And then that would be your answer. If they ask you to graph, obviously graph. If they don't ask you to graph, you don't have to worry about it. It gets a little bit more involved, but not a lot, when you have a variable over here, or if you have multiple fractions. The first step for solving is going to be you need to make one side of the equation equal to 0. And the easiest one to do would be the side that doesn't have the fraction. So I'm going to do that. X minus 2 minus 5 is greater than or equal to 0. Okay, so we're going to try to get one side equal to 0. After that, your second step is going to be to combine this all into a single fraction, which means you're going to need to find a common denominator. Common denominator, at least the ones that you will be asking you to do this year, are going to be relatively easy to find. So you get that. So I'm going to come up with x minus 5 times the quantity x minus 2, all divided by x minus 2. And that's still going to be greater than or equal to 0. Your third step is going to end up being simplify. So you're going to make this all into a very nice, neat fraction, or rational expression, my apologies. So this will be a negative 4x plus 10, make sure you get the negative sign from the 5 to come along, over x minus 2. I could pull out a 2. It's not really beneficial, so I'm not going to worry about it. And then second to last step is, again, like the next two steps are exactly what we ended up doing on the previous problem. You're going to go through and find values that create the denominator, have the numerator denominator equal to 0. So in this case, you would have the negative 4x plus 10 is equal to 0, and worry about that. And then you're also going to have the x minus 2 equal to 0. Now this is the domain one, so that's going to definitely not have anything to worry about there.